Monitoring of Electronic Image Display Systems, Part 3. When referring to LCDs, electric charge is applied to turn a pixel off so that it is dark against a light background. Truly dead hardware pixels are identified by bringing up a solid black background and examining it for white spots. It's also possible for hardware pixels to become stuck in an on state. In this case, we look for black spots on a solid white field. The same methods can be used for color monitors using red, green, and blue fields. These can sometimes be fixed by gently massaging them with your fingertip, but they can also be damaged by finger pressure and fingernails, so it should not be attempted with expensive workstations. The AAPM recommends for Class 1 monitors used for diagnosis, 3 conditions must be met. 1. 15 or fewer bad pixels must exist across an entire screen. 2. There must be 3 or fewer bad pixels within any circle of 1 centimeter diameter. And 3. There must be 3 or fewer bad adjacent pixels. Viewing angle dependence is often referred to in similar terms when you're looking for a flat screen TV or a new computer monitor. Various manufacturers create screens that have pixels set at various angles from perpendicular, but may need to have their brightness adjusted. An objective comparison can be made by positioning a photometer at increasing angles from perpendicular, maintaining a precise distance of 1 meter from the center of the screen. Percentage of luminance can be determined and validly compared to those obtained from other manufacturers. The stability of a self-calibrating LCD should be checked by measuring the stabilized brightness every day for the first week, once a week for 1 month, and then each month for 3 months using a photometer. Luminance testing should occur on all LCDs annually. Prior to the adoption of digital imaging technology, your book estimates a majority of repeat exposures, approximately 60%, occurred due to technical factor errors and/or chemical processing problems resulting in the film screen image being too light or too dark. Today, that number is around 10%, and they are now primarily due to positioning errors by the technologist. Most systems, when rejecting a repeat, have the ability for the technologist to select a reason for the repeat, and the images are archived. Not all systems have this capability, though, and unfortunately, many rejected images are lost. I personally remember being required as a radiography student back in the 1990s, being tasked with sifting through the repeat X-ray bin and documenting the technologist's number of repeats, the reason for the repeats, and calculating the average percentage of repeats. The repeat percentage rate should be kept below 5% for any technologist, and documentation of this has been made avoidable by some digital systems. This is something I would advocate for in a radiology department when the purchasing of equipment occurs, as being aware of the repeat rate provides data to improve technologist performance and reduce radiation exposure to patients.